Okay, here on number 1, we are told that the sand is being piled into a conical base, but here is our volume formula. Okay, the circumference, so we have a circumference of the base, dc, right, the derivative of the circumference with respect to time. And the circumference is 8 pi, find the rate of change of the volume. Okay, so if we're going to find the rate of change of the volume, let's take the derivative of the volume with respect to time. That happens to be 1/3 times 3r squared dr dt. Okay, and we notice in order to take this derivative, I need to know what the radius is. Okay, and also I need to know what the dr dt is. So I'm missing some information here. So we're going to go back to our circumference. I'm sure that's pretty important. So circumference is 2 pi r. Okay, so the derivative of the circumference with respect to time is 2 pi times dr dt. Well, great. This will help us figure out what our dr dt is. Okay, so if the circumference rate is 5, or 5 pi rather, right? 5 pi. That was 5 pi. Sorry, not 5t, but 5 pi. 5 pi equals 2 pi times dr dt. So it looks like our dr dt is 5/2. Okay, fantastic. That's 5/2. Now what about our radius? So to find the radius, I'm going to come in here with my circumference. All right, my circumference is 8 pi, which is equal to 2 pi r. And I think pretty quickly we can determine that the radius of this circle is going to be 4. Okay, so we need to use our other information from our problem in order to find our volume rate of change. So it looks like our volume is changing at 16 times 5/2, which is 80/2, which is going to be 40. So 40, probably cubic somethings per cubic feet per hour. But since there aren't any units in our answer, we just have to say 40.